Hello, everyone, and welcome to this session. It was really great to attend Developer Week Cloud in person last week. And I want to welcome all of you joining us virtually today. Like Garrett said, my name is Rory Schober-Cohen, and I'm a senior developer advocate at Asserto. Asserto is an authorization startup based in Seattle. And today I want to talk to you about fine-grained authorization. And as an authorization startup, we at Asserto have some insights about this. So in the past several years, there's been really a lot of buzz about this topic. And in this talk, I'm going to talk to you about some key ideas and best practices that hopefully would guide you on your own journey to create an authorization system. Let's get started. So first, let's talk about the differences between authentication and authorization. So people tend to lump these concepts together as auth, but they're really two distinct processes. Authentication describes the process of finding out that you are who you say you are. So in the past, we used user ID and password, and in these days, it's much more common to use magic links or two-factor authentication and so on, but basically it's all the same process. It used to be the responsibility of the operating system to basically log you in once you provided a password. But over the last 15 years, we started moving into the age of SaaS and the cloud, and that changed how things worked. So the first generation of SaaS and cloud apps that came online had to basically reinvent this process because now there was really no operating systems to ask to authorize the user's identity. So in the course of the last 15 years, we started to work together as an industry to develop standards around authentication like Auth2, OpenID Connect, SAML. We started using JWTs and so on. And so now nobody really has to build a logging system if they don't want to. There are many developer services that help you to do this. And we've successfully moved identity from on-prem to the realm of SaaS and the cloud. So that was basically authentication. And authorization, on the other hand, is the process of finding out what you can do once you're logged in. So unlike authentication, authorization is a problem that is far from solved. It really is safe to say that identities moved to the cloud successfully, but access control has not. So the problem is that there are really not any standards in this space. So you can apply some patterns like RBAC and ABAC, which we'll discuss a little bit later, but there are no standards because authorization is a domain-specific problem. And there aren't any developer services as well. We really can't think of a Twilio or a Stripe for authorization. And it seems like there are many problems in this space. And because we have no standards or developer services to speak of, companies really lose agility. Because now they have to take time to work through building their own authorization system and go through all the pains that entails. Companies have to think about the opportunity cost because now they have to spend more time developing these authorization systems instead of focusing on their own value propositions. And unfortunately, when companies do this themselves, they really do it badly. And the reason we know that they do it badly is because broken access control as an issue has moved from number 5 to number 1 in the top 10 security issues that was listed by the Open Web Application Security Project, also known as OWASP. And it seems like we really dug ourselves into a pretty big hole, and now it's time to dig ourselves back out. So let's talk a little bit about how we got here. We can really think about 3 transitions that have affected the world of software in general and authorization in particular. First, we moved from software to SaaS. So as we mentioned, identity moved successfully, but access control didn't really move successfully to the cloud. And if we dig into why that was, is we can talk about how in back in the days where we just used an operating system, we had a global directory like LDAP, where you had groups, and then users were assigned to those groups, and those groups would typically map to your business application roles, and things were pretty simple and straightforward. But now we really don't have this global directory that we could query anymore. So every application has to reinvent this process on its own. The second shift that we've seen is architectural, and we moved from monolithic applications into microservices. So back when we had monoliths, authorization just happened once in one place in the code. And now we have a bunch of microservices where each microservice has to do its own authorization. And we also have to think about interactions and authorizing interactions between microservices, which is a new paradigm that we now have to tackle. And the last big change that we can talk about is the move from the perimeter-based security approach to zero trust security approach. And with zero trust, a lot of the responsibility for security moved away from the environment and into the application. So we really have a new world order now where everything is in the cloud, everything is a microservice, and zero trust is a must. Now, unfortunately, not all applications have really caught up with this new paradigm. And we can compare, when we compare well-architected applications to poorly architected applications, we can really point to 5 anti-patterns and 5 corresponding best practices. So the first anti-pattern we're going to talk about today is that every service is doing authorization on its own. Now, if each microservice that we have in our system has to worry about its own authorization, it's very likely that each microservice is going to do it a little bit differently from all the others. And so when you want to change the way that authorization behaves across your entire system, you now have to start thinking about how each microservice has to be updated and how the authorization logic works in that microservice. And that really becomes very hard the more microservices you add to your system. The best practice that we want to consider then is to basically extract all the authorization logic out of all of these microservices, and then build a purpose-built microservice that will only deal with authorization. The second anti-pattern is baking coarse-grained authentication, coarse-grained roles into your application. So we often see this in applications where you have roles like admin and a member, and maybe a viewer role. And all of these roles are going to be baked directly into the application code. And then as developers add more and more permissions, need more and more permissions, they try to cascade those permissions into these existing roles. And that makes the authorization model become very, very hard to fine-tune very quickly. And the best practice in this case is to start with a fine-grained authorization model. And that authorization model should apply the principle of least privilege. And that means we want to give a user only the permissions that they need, no more and no less. And why is this important? Because when the identity is compromised, and this is not a question of if, it's a question of when, that we can make sure that we limit the damage that this compromised identity might cause by, again, limiting the permissions that we assign to the roles that we specify. The third anti-pattern that we see is basically authorization spaghetti code, where developers basically have a bunch of switch and if statements all sprinkled around the code that all govern the authorization logic overall. And that's definitely a bad idea and costs a lot when we want to change the way that the authorization behavior works across the system. And the best practice here is to maintain clear separation of duties and keep the authorization-related logic in an authorization policy. And we're going to talk about what authorization policies are a little bit later. And we want to make sure that these policies are managed centrally. And in that way, by separating the two, we ensure that the developer team is now responsible for developing the app, and the application security team is responsible for security. The fourth anti-pattern is using stale permissions in an access token. So again, this is something that we typically see in the early life of an app, where developers leverage scopes and then bake those scopes into the access token. And for example, we have a user that gets an admin that has an admin scope, and again logs in, and then that scope now lives baked into the access token. And then downstream, wherever that user interacts with our system, the access token is then opened, and we basically pull out the scope and the particular role that is assigned to that user. And why is this bad? Because when for any reason, right, if we want to remove that role from that user and invalidate it, as long as this user holds an access token that has a lifetime, they're going to have access to all the resources that that access token gives them. So that's a very big anti-pattern that we can point to. And worse than that, you can't really have a fine-grained access control model by using access tokens. So for example, we can't specify access to particular resources. It's not really part of the visibility of the issuer of the access token. So let's say we have a collection of documents where we want to give a user a read permission to a document. Well, which document are we talking about? All documents? But we can't really stuff a collection of documents into this access token. So really the best practice here is to assume that the access token never to assume that the access token has the permissions that we need. And instead, we want to have real-time access checks that take into account the identity context, the user, and the resource context and the permission before we grant access to a protected resource. Now, as I said before, we know that unauthorized access is not a question of if, it's a question of when. And an anti-pattern that we see is really neglecting to maintain any form of consistent authorization logs, and that limits our ability to trace any kind of unauthorized incidents. And so what we want to make sure is that we have fine-grained and centralized authorization logs. And we need to really ensure that we're monitoring everything, we're logging everything, all in a centralized place that we can then analyze downstream and get better understanding of what exactly is happening in our system. So in the rest of this talk, I'm going to really dig a little deeper into these concepts and see if there are many kind of best practices and recommendations that maybe you can adopt for yourself. So let's start with this concept of purpose-built authorization service. It seems like it's really the real new hotness in the authorization world. And every company that's created their own purpose-built authorization service is now writing about exactly what they're doing. It all started with the Google Zanzibar paper that described how they built the authorization system for Google Drive. All the other companies that followed really describe how they built their own purpose-built authorization service and then built a distributed system around it. Other than Google, we have Intuit's Auth-Z paper, Airbnb's Himeji paper, Carta's Auth-Z paper, and Netflix Pass paper. And this pattern of these papers coming out is very similar to what happened with DevOps, before DevOps became popularized, where again, big companies wrote about how they were shipping software every week or every day, where most companies were really shipping every month or every 4 months or twice a year or whatever. And eventually all of these learnings from these big companies were transformed into software, and the technology stack was eventually democratized. And authorization is really following a very similar pattern, where we now see all of these companies really writing about all of their experiences, creating these authorization services. And now we're starting to distill these learnings and putting them into software. So let's talk a little bit more about fine-grained access control and how it came to be. And we'll take a little trip down memory lane and see how this concept evolved. So back in the 80s, we started with ACL. Operating systems really didn't just do login. They also did access control. And that access control was on files and folders. So you can ask a question like, does Alice have read access to this file? And that pattern was called access control list. The next pattern came around the 90s and the early 2000s, and that was RBAC, or role-based access control. It came about with the advent of directories like LDAP or Active Directory. And what the directories gave you is the ability to create groups and then assign users to groups. These groups would typically correspond to a particular role in a business application, and then an admin would just assign a user to a group to give them the appropriate permissions. And then everything was really done in one console. Life was pretty simple, and it allowed you to ask questions like, is Bob in the sales admin role, for example. The next evolution was what we call attribute-based access control. And that's where really where we started seeing fine-grained access control. So in the early 2000s and 2010s, we saw standards like XAML, which stands for Extensible Access Control Markup Language. And that defined really how to do fine-grained access fine-grained permissions based on attributes. whether we're talking about user attributes like what department the user was in, or resource attributes like what folder is the user trying to access, or maybe even environmental attributes like what was the user's geography, or what was the current time. And then that let you answer questions like, is Mallory in the sales department? Is the document in the sales folder? And is it currently working hours in the US? And last but not least, we have the Zanzibar paper and the sort of reemergence of ACL and RBAC worlds with this authorization model called REBAC, or relationship-based access control. And in this model, we basically define a set of objects that are typically your users or groups, and then a set of objects, which are things like organizations or directories or folders or maybe tenants. And then you define whether a particular subject has a relationship with an object. So I would have a viewer or an admin or an editor. Those would be relationships between a user object and, say, a folder object. And you could really ask very complex questions by traversing this relationship graph that is formed by these subjects, objects, and relationships. I'm seeing some questions come in. Maybe we can address them. Yes, so a scope could be a context, and it could include a role. Yes, and we've seen this happen many times where people define these roles and stuff them, again, like in the context of access management of an access token, they stuff those as a scope into the access token, and it is truly an anti-pattern, like I mentioned before. Okay, so we've really seen two ecosystems emerge around this concept of fine-grained access control, fine-grained authorization, sorry. The one is policy as code, which is the successor to ABAC, where the Open Policy Agent project is really the lead project in this camp. In this paradigm, we express policies as a set of rules written in code, particularly in the Open Policy Agent, or OPA project. We use the Rego language. OPA is a CNCF graduated project. It's a very general purpose, very flexible decision engine, and it's built for policy-based access management and ABAC. On the other hand, the language that it uses, Rego, is a data log derived language. It has a pretty high learning curve, and it doesn't really help you with modeling application specific authorization because it's really truly general purpose. So that means that you basically have to build everything for pretty rudimentary building blocks. It also doesn't really help you with getting the user and resource data that is relevant for your decisions to the engine. And this is important because the authorization process, the authorization decision has to take place in a very short amount of time, since it's a bottleneck on your application. And that means that you now have to solve this distributed systems problem yourself. If you really want to build an authorization based on OPA, it's a really good place to start. But like I said, you're going to have some hurdles to jump over. Now, the second camp is the policy as data camp, where the policy isn't stored as a set of rules, but rather is ingrained in the data structure, the relationship graph itself. It's a very opinionated model, so you don't have to design the model to begin with. Like we said, we have subject, objects, and relationships, which gives you a lot of flexibility. These are very generic primitives that you could apply to your model. And so if your model fits this authorization model, if your domain model fits this authorization model, it's a really good place to start. On the other hand, it's still an immature ecosystem. There are not a lot of open source implementations for this, and it's hard to combine it with other models like RBAC and ABAC. Now, let's talk about policy-based access management and what it really means. As the name suggests, we really want to lift the authorization logic out from our application and into a policy that is its own artifact. And we'll discuss what the benefits are again in a minute, but I just want to show you an example of a policy that's written in Rego, again, the language used by OPA that we mentioned before. So we have our namespacing in the first line of the code here. That basically tells us what is this package, what endpoint is it working with, and then following that we have a set of default definitions for the decisions that this policy is going to produce. And this is really where the zero trust principle is coming into practice. And you can see that we're denying access, for example, in the allowed clause, we're denying access until we have enough proof to grant it, right? So the policy is gonna return allowed equals false unless we have some reason to change that and make allowed be equal true. So on line 9, we can see that we're checking the user's department, and we're making sure that it equals operations. And if it does, then this allowed clause will evaluate to true. Now, let's take a quick look at what the application code looks like after we've extracted the authorization logic into the policy. So the code snippet you see here is an Express.js endpoint that uses a piece of middleware, and that check auth z middleware basically calls our authorization service. It's responsible for passing the user identity that was verified by the check JWT middleware. And then if the allowed clause from the policy returns true, the middleware will pass the request to the next function. And if not, it will return a 403. So why do we want to do this? Why do we want to separate authorization from our application? So again, first, we now have a separate artifact and that means that we can now store and version our policy exactly the same way that we would our application code. Every policy change that we're going to have is going to be part of a git changelog, just like an application, which gives us a really nice audit trail for any changes in our policy. And now that the authorization logic is separate from the application code, we're now keeping this principle of separation of duties. Our AppSec team can manage the authorization policy, the developer team can focus on working on the application, and everybody's happy. And then finally, when we have this artifact, we can build an immutable image and sign it. And that way we're maintaining a secure supply chain, which is a really, for this really critical component of our security strategy. If you want to use this tool, I'll gladly share the link to this open source policy CLI tool that helps you with building and signing policy images. The last topic I want to really discuss is real-time access checks. And as we mentioned before, you want to make sure that we're doing real-time access checks and not using stale permissions that were stuffed to access tokens. But this is a really hard problem to solve. There is a reason why we don't see developer services that tackle this. And the reason is because when this is done correctly, building an authorization system is really a distributed systems problem. And as we know, distributed system problems are not trivial to solve. So let's get into the details here. The first challenge that we have to face is that our authorization service has to perform the authorization locally. And the reason for this is, again, authorization, unlike authentication, is really in the critical path of every single application request. So authentication happens once when we log in and then we're done. Authorization happens for every request that tries to access a protected resource. So an app doesn't want to take dependencies on something that lives across the internet. It requires 100% availability and milliseconds of latency. So our authorizer has to be right next to the application to ensure this availability and latency requirements. So we want to really compute the authorization decisions using some form of cached policy and cached user and resource data. But at the same time, we really want to make sure that we're managing all of our artifacts centrally. So we want a control plane that will manage the policies, the user directory, and all the resource data. We want to aggregate decision logs that come from the local authorizer. And we really want a high-speed event and data fabric between the control plane and the local authorizer. We also want the control plane to connect to some external tools. So we want to connect external identity providers to our directory. We want to have source control repos to maintain our policies code artifacts. And we really want to be able to aggregate and analyze our decision logs with popular logging systems like Elk, etc. So I want to leave you with these 5 laws of authorization, which were coined by our CEO, Omri Gazit, as a homage to Kim Cameron, a giant in the identity space that coined the 7 laws of identity. And these are, we want to have our authorization model be fine-grained. We want to support this consistent model, be it RBAC, ABAC, or REBAC, that would fit our application domain. We want our our authorization model to be policy-based, so that we can extract the policy out from the app and into its own artifact, so that we can then build and sign it. We want our authorization checks to be real time. So authorization has to be a local call, and it would have to execute over fresh user and resource data that comes from our control plane. We want to centrally manage all of our policies, our directory, our resource data in a central way. And we want to have decision logs that are aggregated and stored centrally, so that our organization is compliant and that we have a full forensics trail. And then the last three concepts here are to just ensure that there's good adoption of our authorization system internally. And those are, we want to make sure that our solution is developer-centric, that authorization can happen with a single line of code and not more. We want to have easy integrations with identity providers, source code repos, artifact registries, and logging systems. And we want our solution to be built around cloud native and open projects like open policy agents, to really harness the power of the open source community and the ecosystem at large. And if you want to build your own authorization systems, you're more than welcome to do so, and we would be very happy to help you on your journey. Just reach out to us at acerta_com. And if you don't want to build your own authorization system, well, you guessed it, we would love to help you as well. Drop us a line at hello@acerta.com with this code, developercloud 2022, to get 25% off your first year if you sign up by October 1st, 2022. Okay, so thank you, everybody.